Okay, time to move to the next item in the agenda. Will be a presentation from Sujith Samuel. He joined us today to share the Nokia journey with Flyte from PoC to production. Welcome, Sujith, and thank you for joining.
Right. Thank you. Thank you, David. You can hear me, right? Yeah, good. So, thank you once again for having me here to talk about how we uh, did moved from POC to production with Flyte. Yeah. So, uh, to give an overview, I'm the chief ML engineer here at Nokia, uh, and I work for the Nokia standards unit, which is like one of the business verticals here in Nokia. And we have our own machine learning platform, which we started developing around 6 months back. Incidentally, I joined Nokia 6 months back, and prior to that, I was in Ericsson doing the same thing. So I just gained some experience and then tried to implement whatever I learned over there. So over the past 6 months, we have been trying multiple open source softwares, trying to put them together, glue them together, and try to provide a composite experience to the final data scientist, so that they have to just log on to a single UI and do all their activities. So we have Jupyter for small experimentation. We have a VS Code IDE wherein you can basically put all your code. Then our workflow orchestration is Flyte. So we basically submit our jobs to the Flyte, and Flyte takes care of running the training pods. And we have trainings that run from 3 hours to anything between 3 hours to 5 days. So we have uh, trainings that run for a long, long period of time. And we have around 100 users who are using the platform currently. And at the start of it, we had uh, we did POC with around 10 to 15 users, and it was good for us. So prior to this, I had worked with Argo, and now I work with Flyte. So uh, okay, next slide. You can go to next slide. Yeah, next slide, please. So why Flyte? Yeah, I mean, if you look at my experience with Argo, right, it has been kind of like you have to build a YAML, and data scientists, if I ask them to have a deployment YAML, have a build YAML, or have their workflow as a YAML, many of them look at me like, what is YAML? Why are you asking me to do all these YAML activities? On the other hand, if I just ask them, just use a decorator, put it on top of your Python function, and just be done with it, uh, they are they become kind of more friendly towards me in that sense. So I believe one of the primary reasons was that it is very closer to the actual code. Yeah, I didn't have to ask the data scientists to actually make an image, create some entry points, then create a YAML, and then submit it to the orchestrator and all that kind of activity. So Flyte took care of all that. So I think that was fine. I think it is like one of the big pluses that I had with Flyte. It was also very easy to set it up with Keycloak, and actually I had a lot of help from the Flyte community. I mean, I raised a lot of queries on the Flyte Slack, and then there were a lot of help available. It is easy, and also a lot of help is available. So that basically is like the primary reason why we thought, okay, let's go with Flyte and let's see how the experience is. And so far it has been really good. So we didn't have any stability issues with Flyte. We didn't have any major data scientist dissatisfaction with Flyte. Basically, they come, they code Python, they add a decorator, and then that's it. They're done with it. Yeah. Next slide, please. So this is how it looks like. We have a Azure AD, then the Keycloak, then Istio is the service mesh manager, and then we have a Flyte. And Flyte is the only thing that I'm talking about here. So hence I have put only Flyte as the big box. But actually we have a lot of other components like ML Flow, Jupyter, and all these are tightly integrated with each other. So you submit something in Flyte. We have an ML Flow integration that actually logs everything that happens in Flyte, all the experiments that go to ML Flow. So that's how we have tightly knit this together to provide this composite experience. And Flyte is like the central part wherein we run all our batch trainings in Flyte. and then our models are getting stored in backend storage, from where we pick up for inferencing with Selden or other frameworks. So that's how it has been. Yeah, next slide, please. Yeah, so generally how it is, like we have a workflow. How does it reach Flyte? Yeah. So user codes in VS Code. Then we have given them a plugin which basically uses their code. We have a Kaneko build process that Kaneko builds the entire workflow, entire image, and then Flyte packages that image and sends it to its UI. I mean, sends it to the backend, like wherein all the it basically segregates into workflows. Each workflow segregates into task, and each task has its own, you know, uh, protobuf things that it tries to put into S3 and all that. So that's how it basically works. So we have a, a process from where a user can just use his code and push it to Flyte via Kaneko build image. So that's how it works. So Flyte kit, then there are multiple tasks on the workflow, and then it generates an image that runs on the execution engine. Yeah. And execution engine is something that I will talk about in the next slide. Yeah. So here I have explained the process. Yeah. So we have a Flyte workflow. Yeah. So what happens is, uh, if you look at our the way that we are structured, right? We When we started off, we did not have GPUs on our cluster, yeah, on our own cluster. So we had to submit jobs to an external system, yeah, and that external system is not Flyte. Yeah, external system has no idea what Flyte is. Yeah, so external system basically is like a container engine. You can think of it as a container engine orchestra running system. Yeah, so you submit the jobs there, and then it is up to you to tell the container what to do. So we basically hacked into the system by giving entry point as a PyFlight execute. So if you look at Flyte, how it triggers each node is, it calls the image, then it provides the arguments like PyFlight execute, and then it provides the argument as steps as argument, and internal project ID, and all those kind of things. It provides as environment variables. So what we did was, we took all those environment variables, we trapped them, and then we sent it to the external system. And then we asked the external system to actually execute PyFlight execute commands with the same environment variables, and it worked just fine. So, and how we did that? We actually used Python decorators. So we have the decorator. What it does is, it basically traps all the environment variables. It understands whether I'm executing on Flyte or I'm executing on the external system. So first, the workflow, when it executes, it actually executes on Flyte, and then the decorator realizes, oh, I don't have GPUs, what should I do? I should go to the external system. So at that point in time, the decorator packages everything and sends it out to the external system, asking. So in our case, the external system is the LSF cluster. LSF is an IBM software load sharing facility which has all the GPUs. So we ask LSF to run the image with all the environment variables and the entry point, and then it runs. And then we have a watcher on the LSF which basically sends the information back to Flyte, and then Flyte understands that, okay, this step is done, then the Flyte triggers the next step. So that's how we set this entire system up. Now we have on cluster GPUs, so we have the capability to execute jobs on our own GPUs on the LSF cluster, as well as on any standalone VMs which might have GPUs or not, which might not have GPUs. So this is the entire system. And again, I stress here that it is because of the ease of with which we were able to customize all this, that we were able to implement this as a platform. And it is kind of impervious to the backend or to the user as to where his job is executing. All he sees is a Flyte UI, and on the Flyte UI he sees that his steps are executing one by one. But under if you look under the hood, then it will be like a lot of different processes that hack into multiple things in Flyte, and then send the job outside, then trigger, watch the job which are happening outside, and send it back to Flyte, and then Flyte knows that, okay, the job is done, and then it triggers the next step. And that's how it goes. Yeah, next please. What do we need to do now? We had a discussion. I think I also put it on the Slack there, that We need to eliminate decorators and start creating backend plugins. So LSF doesn't have a backend plugin right now because we thought it is like, as of now, we are not investing too much time into creating backend plugins for LSF. But in the future, when we try to move on to multiple execution systems, then we definitely need something that is easier, not so much hacky as what we have. So we would definitely want to create some backend plugins. Yeah. We also want to scale up Flyte to more nodes. So right now we have around 40 to 50 nodes, which is for a team of around 120 people executing experiments, round the clock. We want to move it up and see what is the limit. Like I've seen blogs where Flyte has been running with thousands of nodes. I've seen some blogs, so I'm hoping that this should not be an issue. But that is our plan that we want to do, and we also have plans to move our platform as a product. And when we move it as a product, then we would definitely like to have some user isolation between multiple teams. Like now, if you see that we have a single Flyte UI, all the experiments show up on the Flyte UI. Yeah. How do you ensure that a team can only see its own experiments? I'm not so sure how it happens right now in Flyte. I have not explored it, but we have to understand how to isolate the different Flyte experiments and make it visible only to the team that has done the experiment. Next slide, please. Yeah, and finally, a big thanks for the excellent community support. Yeah, I mean, I have never had to wait for more than 1 hour. I mean, 1 hour is also too much. Yeah, I have never had to wait basically. Once I post something on Slide, the response is kind of instant. Yeah, and everybody from Ketan till everybody just is shows exceptional willingness to come onto a call and resolves the issue. Yeah, and yeah, like I said, thanks to him. And last but not least, entire Flyte team has made such a great product. Like I said earlier, just Python, a decorator, annotation, and that's it. I mean, we are done with it. We don't have to really worry too much about YAMLs and YAML syntaxes, because a YAML is one thing and YAML syntax is one thing. Because if you miss a hyphen or if you miss a space, YAML will not run, but it will not tell you why it not run. So so yeah, I mean, that is something that I have faced, and it's a good thing that Nokia uses Flyte, and I have learned a lot about it, and I'm thankful to the Flyte team for making such a great product. So thanks, guys. Thank you once again. I think next slide, and I should be done with this. Yeah, yeah. Thank you. Thanks a lot.
Thanks to you, Sujit. That's awesome. Any question, any comment for Sujit?
Yeah, Sujit, the last point you made about viewing only the experiments that a team is responsible for, this is something um, we'll make an RFC for this, but we've been knocking around some ideas on execution tags. That's the key phrase there. Basically, you can tag a set of executions with whatever you want, and then kind of filter them in the UI or programmatically after the fact. So that's something. Well, we have a lot on our plate, but that's definitely on the top of our list. So would love feedback. We'll share this with the community, and if you want to help kind of design what this looks like in the end, yeah, we'd love your feedback.
Yeah, definitely. Yeah, I mean, like I said, this is a centralized platform, and now initially when we started off, it was only our team. Yeah, but now there are a lot of other business units who are showing interest in this, and because of the ease of the use, right? I mean, everybody is kind of okay to use this, and with that comes user isolation, uh, project isolation, experiment isolation. So the way that we are doing it in MLflow is we are actually having multiple MLflow instances for multiple teams. But Flyte is I don't think I can deal with Flyte. I mean, I can do it, but then it becomes too big for me to manage multiple instances. So yeah, it would be a great thing if this could be done somehow. Thank you.
Okay, cool, great.
Awesome. Any other question, comment?